Hello class, this is the video for section 5.6, solving logarithmic and exponential equations. The following are our learning objectives: solving logarithmic equations, exponential equations, and also exponential equations that is quadratic in form or quadratic in type. Okay, we'll see what it is. All right. Now, here we just going to review quickly or remind ourselves of the definition of what a logarithm, that you have y equal to the log x base a, if and only if the exponential, all right, what must you raise the a to get the x, that is raise the a to y and then get is equal to x, where a is greater than 0 and a is not equal to what? 1. And then this property that the log of m base a is equal to the log of what? N base a. When they have the same base, all right, then we can drop the what? The log function and say that m is equal to what? N, where m, n, and a are positive and a is not equal to 1. But that does not mean this is the only properties that we're going to use to solve equations involving logarithms. Okay, so this and all other what? Other properties that we have what? We have learned. Okay, we learn in what? In section 5.5 that we talked about the previous video. All right, so let's take some examples. First, it says solve the equation 4 times log x base 6 equal to log 16 base 6. Now, remember the property is this: m base a equal to log n base a. Then we can say that becomes what? M is equal to what? N. But in this case, each of these on the left hand side in this property, they must be a single what? Logarithm. But looking at the left hand side here, you have 4 times that it is not single, it is one term, but it is not put in the what? The simplified form. That should be, so that means we can use some property to what? To write in this as a single what? Logarithm there. All right. So, but first, we need to what? Look at the domain of the variable x in this equation. All right. And the x, the log is defined when x is greater than what? 0. Okay. Note that each logarithm has the same what? The same base. And so we can use the property that we just talked about. Okay. Now use properties of logarithms to solve the what? The equation. Now let's give a remark. It is very important to determine the domain of original equation as we have done. All right. Or simply check your solution at the end, because there could be extraneous what? Solutions. Okay. I'll show you why or how that is done. Okay. So given this equation, we want to write this because we can use one of the properties, all right, that to simplify what? The left hand side of the what? Or the equation. All right. And that property is this. So whenever you have what? R times log m base a, it becomes what? Log m to the r. Okay, this r goes to the top there, and you have that. So because this is not in that form, we write it in that form. So therefore it becomes what? Log x to the base 6, and then x raised to the 4 is equal to log 16 base what? Base 6. And now we can say that this is equal to what? X to the 4 is equal to what? 16. Okay. And what property is that? Okay, that is this property that we just talked about. Okay, so this is my n, the whole of this, and this is my what? This is my n. Okay, this is the whole of this is my m. All right, so then let's bring this to the other side. Okay, so if you have this, you have what? X to the what? x to the 4 minus 16 is equal to what, 0? And difference of two squares, so we have what, x to the squared plus what, plus 4. And then you have what, x to the second minus 4 is equal to 0. So if you set it to 0, you have what, x squared plus 4 equal to 0, or x squared minus 4 equal to what, 0. All right, now if you have x squared is equal to negative 4, and then you have x is equal to the square root of what, minus 4, or you have x squared is equal to 4, and then x is equal to plus or minus the square root of 4. This is plus or minus. Well, this is not possible. Okay, this is not a real number, so it's not real. Okay, so this would give me plus or minus what, minus 2. Okay, so that is what I have here. It says that x is equal to minus 2, or x is equal to what, positive 2. Now, since we know that x is greater than what, 0, okay, this is what, it's an extraneous, that is x equal to negative 2 is extraneous, and therefore we don't include it in the what, in the solution. Okay, so let me, okay, all that we have there is that since the domain, okay, since the domain of the variable in the equation is what, is greater than this, negative 2 is an extraneous what, solution, and therefore we what, we discard it. Okay, we discard it. So this is equal to, let's write here, have x is equal to plus or minus square root of 4, and that is what, plus or minus what, 2. Okay, so what is the solution set? We can say that the solution set is what? It's this, that is 2, or we can have to check the solution, whatever it is, we have to check it, and then be able to write the solution set. Okay, so we go to the next and then check it there. Now notice that here we are checking that x is equal to positive 2. All right, so when we plug it in, this x is equal to 2. This is going to be 4 log of 2 because s is 2. And then we use the property, okay, this property, and write it as what, log 2 to the 4 log base what, base 6 is equal to log 16 base 6. And then that is what, 2 to the 4 is what, 16. So you get log 16 to the base 6 is equal to log 16 to the base 6. And then we see that this is what, this is check. And therefore the solution set is what, is that. Okay, so either we use the domain to write a solution set, or after that we have to check it for what, both of them. Of course, x is equal to negative 2 will not work. Let's try it. If x is equal to negative 2, you get 4 log of what, negative 2, okay, base 6 is equal to log of what, 16 base 6. Of course, log is this one, the log of negative 2 is what, undefined. Okay, it's undefined. Okay, so we can't even go further to even check that at all. All right, here's the next example. Solve the equation log x plus 9 base 20 plus log x plus 2, so x plus 1 base what, base 20 equal to what, equal to 1. Now I want to know that the base, okay, the base is 20 in each of these two terms on the left hand side. Okay, but if you want to know the domain, we have to pick each of them. That is x plus 9 must be greater than 0, and x plus 1 must be greater than 0. And then we find a combination of the two. Okay, that's what it is. So you have x plus 9 greater than 0, and x plus 1 greater than. So for this one, you have x is what, greater than negative 9. And then for that one, you have x is greater than what, negative 1. Now, if you put these together, then x greater than what, negative 1 is what, is a 1, that will have all the values that will satisfy what? Both the first term here and then the second term. Okay. So to obtain the exact solution, first we want to express the left-hand side as a single what? Logarithm. And then we change the equation to what? To exponential form. Okay, so let's go ahead. So what we have there is this. All right, we write it as a single expression on the left-hand side. Okay, we know that when you have the sum, which is plus, it becomes a product. So this is what becomes log, okay, x plus 9 times x plus 1 to the base what? 20 is equal to 1. Now here we don't have log on the other side, so don't take log. Okay, because use the definition of log, which says that if you have log what? X to the base a equal to y, then this becomes what? X is equal to a to the base to what? To y. Okay, so then we're going to write this as what? X plus 9, x plus 1 equal to what? 20 raised to 1. Okay, then when you distribute the left hand side, you have, okay, if you distribute the left hand side, you have what? X squared, okay, plus x plus 9x plus what? Plus 9 equal to what? 20. Go 20 to the 1 is 20. Now bring this over, bring it over to the left hand side. You have what? X squared plus 10x, okay, minus what? Minus 11 is equal to what? Is equal to 20. So let's factor this. You get two factors. Okay, you have what? X x plus 11, x minus 1 equal to what? Equal to 0. So set it to 0. You have x plus 11 equal to 0, or x minus 1 equal to 0. And that gives us what? X is equal to 11, or x is equal to what? Positive 1. But remember, what's the domain? Now, x is equal to 1 will be the one that satisfies the restriction on what? X is greater than negative 1. Okay, that's the domain of what? Each of the what? X plus 2, 9, and then x plus 1. Okay, therefore, x is equal to negative 11 is an extraneous what? Solution. And so we discarded it. Okay, therefore, the only solution set is going to be what? X is equal to 1, which will satisfy both of them. But what we have to do is we can check the solution to make sure that is correct. Okay, so we can check it. Check it for what? X is equal to 1. So this gives us what? Log, okay, 1 plus 9 base 20 plus log base 20, 1 plus 1. Is this equal to 1? So we have log, okay, 10 plus log base 20 anyway, and then 2. Is it equal to 1? All right, so the sum becomes a product. So that gives me log, okay, 10 times 2 base 20 is equal to what? Is equal to just 1. All right, that gives me what? Log what? 20, 10 times 2 is 20. Okay, log 20 base what? Base 20 is 1. So this is 1 is equal to 1. So because log of a base a is equal to 1. Okay, it's one of the what? One of the properties. All right, so we check that the solution set is there, and therefore we can say that the solution set, okay, the solution set is what? Is as we got before. All right, so if I didn't use the domain, find the domain first, what I could do is that after I've got a solution, I have to check it for both solutions, negative 11 and then what? Positive 1. And then you can see that one of them will be extraneous. It is easier if you get a domain, it eliminates one of them entirely. And so you don't have to check for both of them. You check for just one that satisfies the restriction. Okay, here's another example. involving natural log. Okay. So we find a domain. First was the domain of this one, the domain of that, and the domain of this, and the one that satisfy all of the three. Okay, so what we've done that we know for this term here, x is greater than 0. Okay, for that term you have what, x minus 1 greater than 0. That gives me x is greater than what, positive 1. And then the last one, which is x plus 15, x plus 15, okay, greater than 0, x is greater than negative 15. Okay, so which of these, okay, satisfy all the three? This is greater than 0, this is greater than 1, this is greater than negative 15. Okay, when x is greater than 1, it will satisfy all the three. It is greater than positive, is greater than 0, is greater than what, negative 15. So there's the variable x must satisfy what, this restriction, and therefore that's a domain. All right, so we begin the solution first. Okay, we have to write each side as a single what, logarithm. Since this is a natural log and this is plus, you know the plus becomes what, a product. Okay, property to do that. So let us solve this together. First, we write it as a what, a single. The sum becomes a product. So this is what, natural log of what, x times x minus 1 equal to the natural log of what, x plus what, 15. Okay, then the next step is that we can drop the what, if I have the natural log of m equal to natural log of n, it becomes what, natural, just m equal to n. So this whole thing is my m, and that is my what, that is my what, n. So this is x times x minus 1 equal to x plus what, x plus 15. So we distribute the left hand side, give me what, x squared minus x is equal to x plus what, plus 15. Okay. All right, so we distribute and get that, then we group like terms. We get what, x squared, okay, minus x, then minus the x, subtract, and then minus what, 15 is equal to 0, giving us what, s squared minus 2x minus 15 equal to what, 0. All right, then we find the what, we factor this quadratic what, equation. We place in the standard form, and then we find that we factor. So that is what, x, and then put x, and then we have two factors of negative 15. When you add, you get what, negative 2. Of course, that will be what, minus 5, and then plus what, 3 equal to 0. All right, so you have set each of them to 0. We get what, x is equal to, so you have x minus 5 equal to 0, or x what, plus 3 is equal to what, 0. It's giving me x is equal to 5 and s is equal to what, negative 3. But we know that the variable, but okay, x must be greater than what? Greater than 1. And so the x is equal to negative 3 is what? And what, extraneous what, solution. All right. It's an extraneous solution. And so the only solution set is what? This x is equal to 5. All right. So the solution set is what? X is equal to what? 5. Okay. So like we said, we can check, but we don't need to. We can check this and then simplify that and be able to write the solution set. But because we have the domain, it is easier to find a solution set for that. All right. Now, we want to use the property that if you have the bases are the same, then the exponents must be also be the same. Okay. This happens, but what if you cannot write as a base, then we take the natural log or the common log on both sides. Okay, that's how we have used this property. So here is an example. We have 3 to the what? 3 to the x is equal to 7. As we can see, we cannot write 7 as a powers of what? Powers of 3. Or neither can we write a 3 as a powers of what? As power 7. So what we do is that we take natural log on both sides of what, the equation, or we take a common logarithm. Whichever you do, common log, which is to the base 10, or natural log, you will get the same what? The same answer. Okay. So we want to solve this. This time, let's take a natural log of that. All right, so we have take natural log. We have natural log of 3 to the x is equal to natural log of what? 7. Okay. And then we use one of the properties, right? We use one of the properties that says that this becomes x natural log of 3 is equal to natural log of what? 7. Now we are solving for x. Okay, we're solving for x. That's a property. We're solving for, so we divide both sides by what? Natural log of 3. Natural log of what? 3. Okay, so this cancels that. So you have what? X is equal to natural log of 7 divided by natural log of what? 3. Okay, this is the what? That's the exact what? Solution. If you simplify this, okay, natural log of 7 divided by natural log of, you simplify, you get what? You get this solution to the 3 decimal places. So this is the exact solution, okay, to the equation. Okay, now will you get the same answers? Yes, if I take the common log on both sides, all right, so that to be log to the base 10 of 3 to the x is equal to the log to the 7. So use the same property, it becomes x times log of 3 is equal to log to the base 10 of what? Of 7. Then divide both sides by log of what? 3, and divide both sides by log of what? 3. All right, so then your x is equal to log to the 7 over log to the third. Now, if you evaluate this, you will get what? 1.771. It will be the same what? The same answer. Okay, so either you take natural log, all right, on both sides, or you take what? Common log, or the log to the base 10 on both sides. Each will give you the same what? The same solution. Okay, so what's your solution set? Please remember, the question didn't say they are rounded to a certain decimal place. So we have to use the exact word solution. So that is why we have it as what? Natural log of 7 divided by natural log of what? 3, or the solution set could be this. Now log of what? 7 divided by log what? Log 3. Okay, so in doing your homework, note if they want you to express as a natural log, then you use and take the natural log on both sides. If they want you to take it as use a common log, then you take log to the base 10 on both sides. All right. So either or will give you the same what? The same results or answer. All right. So here is another question. Remember, we have this property that what if a raised to what? U is equal to a raised to v, then this yeah, excuse me, then what? U is equal to what? Is equal to v. All right, but again, so you have to check, can I express both sides as what? To have the same base as in this property? No. So then we have to what? Take either natural log or log to the base 10. So I will stick to one, take natural log all the time. All right. So then this, before we can even take natural log, okay, we have to what? We can divide both sides by what? By 5. Okay. So then we have what? 4 to the x is equal to 3 over what? Over 5. So now I can take natural log on both sides. Take natural log on what? Both sides. Okay. And that gives me natural log of 4 to the x is equal to natural log of what? 3 over 5. So please don't write as a decimal. Just leave it. Use the exact. Okay, unless the question says round it to a certain decimal, and do that at the end of the solution. So this becomes x is equal to x times natural log of 4 is equal to natural log of 3 over 5. All right, put in parentheses. Therefore, divide both sides. This is times. Divide both sides by natural log of 4 and then natural log of 4. This cancels out. And so your x is equal to what? X is equal to the natural log of 3 over 5 divided by natural log of 4. And approximately that equals what? Negative, okay, that's equal to negative 0.3685 to 4 decimal places. Okay, now, so what's the solution set? It's going to be the exact. Okay, this is the exact solution. Okay, what we have there is an exact solution. All right, so that is it. All right, now here's another one. Okay, I can take log to the base 10 on both sides, or take natural log on both sides. Whatever it is, you will get the same results. So I'll just show you. Even though I said I'll stick to the natural log, but let me, in this particular one, let me use take log to the base 10 and also take log to the base e. That's the natural log. Okay, so what we do is that we want to take, I'll solve in both ways. So take, okay, log, take common log on both sides. Okay, so that gives me log to the base 10 of 7 x minus 3 is equal to log 2 raised to 2x plus what? 1. Then we use the one of the properties and bring this to the front. That'll be x minus 3, put in parentheses, times log to the base, to log 7 to the base 10, and that becomes 2x plus 1, and then log what? Log 2. Okay, we are solving for x, so we have to distribute. This is a number, so log to the base 7 is a number. So this becomes x times log 7 minus 3 times log 7. This distribute, and then the right hand side becomes 2x log of 2 plus 1 times log of 2, which is what? Log 2. Okay, so we bring all the terms involving what? The like terms together, in terms of the x to the left hand side. So let us add 3 log 7 to both sides, and then this will be plus what? 3 log what? Log 7 to both sides. So this cancels out, and then we're going to subtract 2x log 2 on both sides, and then 2x log what? 2. So what we have there becomes x log 7 minus, minus 2, we're going to subtract, minus 2 x log what? Log 2 is equal to the log 2, which is already there, plus the 3 log what? Log 7. Now factor x from the left hand side, common factor, so x is out. So that gives me log 7 minus 2 log what? Log 2 equal to log 2 plus what? 3 log what? Log 7. Now we are solving for x, so we divide both sides by what? Log 7 minus 2 log 2. Okay. Divide this side by log 7 minus 2 log what? Log 2. So this will cancel that. Okay, so your x, okay, your x is equal to the log 2 plus 3 log 7, and then log to the base 10. So that log 7 minus 2 log 2. Okay, so if we evaluate that, okay, if you evaluate this will give you approximately 11 point what 667 what 2. Okay, that is the what, that is the approximate solution. But the solution set, okay, the solution set will be what? But this whole thing, log 2 plus 3 log 7 divided by log 7 minus 2 log what? Log 2. So that's my solution set. Okay. Now I'm going to solve this, but this time I will take what? Natural log on both sides, and we should get the same answer. Okay. All right. So we have the same equation. This time we want to take natural log on both sides. Okay. So first you take what? Take natural log on both sides. Okay. So this is what natural log ln of what? 7 to the x minus 3 is equal to the natural log of 2x plus what? Plus 1. So we use the same properties, all right? That is what? Log, if you have Rm, then this becomes what? Whether it's, sorry, this is natural log. R times m, it becomes what? Natural log of m raised to what? R. Okay, so then this is what? X minus times natural log of 7 equal to 2x plus 1 times natural log of what? Natural log of 2. So we distribute just like we did. That'll be x natural log of 7 minus 3 natural log of 7 is equal to 2x natural log of 2, okay, plus 1 times natural log of what? 2 is what? Natural log of 2. And so we bring all the terms involving, move this to this side, and then bring this to what? To the other side. So that gives me x natural log of 7 minus 2x natural log of 2 equal to the natural log of 2, which is already there. Okay, then plus what? 3 natural log of 7. Okay, you factor x out, so that gives me natural log of 7 minus 2 natural log of 2 equal to natural log of 2 plus 3 natural log of what? 7. And then you divide both sides by what? Natural log of 7 minus 2 natural log of 2. And this side 2 by what? Natural log of 7 minus 2 natural log of 2. Okay, so that gives me x is equal to that. S is equal to that. Okay. And then when you take the approximate that value, it will be what? To be the same as what we got. So x is approximately, this is the exact solution. And that is approximate what? Solution. Approximate solution. Okay. All right. So what's my solution set? That is it. Okay. So either you have it in terms of common log, logarithms, or natural log, you get the same answers if you evaluate them. All right. Good. Okay. So here is the the last example where we say that you're going to get a quadratic in what? In form. Okay. You're going to get a quadratic type of equation that solve it. All right. So what is happening is that I want you to note that when you have, this is 3 to the what? To the x. If I have 9 to the x, you know that I can write 9 as what? 3 squared. So you have 9 to the x. You have to know that it's the same as 3 squared all raised to what? X, which will give me 3 to what? 2x. Okay, now also know that this is the same as what? 3 to the x times 3 to the x, because 3 to the x times because they have the same base, we can write it as what? 3 raised to what? X plus what? X. And that gives me 3 raised to what? 2x, which is this expression right there. Okay, so then what we do is that we're going to use some substitution method. Okay, this is going to be quadratic because of the substitution. So then the equation 9 to the x plus 3 to the x minus 12 is equal to 0 becomes, we're making this substitution, this is what? 3 to the x times 3 to the x, then plus 3 to the x minus 12 equal to what? 0. So make the substitution. Let u equal to a 3 to the x. That's where you see as a quadratic. So 3 to the x times 3 to the x becomes what? U times u plus what? U minus 12 equal to what? 0. Okay, and that gives more u squared plus u minus 12 equal to what? Equal to 0. Okay, so this is quadratic. So we factor, okay, u, and then u, just like I have in terms of x. That gives me minus 4, then plus what? 3 equal to what? Equal to 0. All right. So something happens. What happens that then your u is equal to either 4 or u equal to negative 3. But you substitute back. But we know that u is equal to 3 to the x. And therefore, this first equation becomes what? 3 to the x is equal to 4, or 3 to the x is equal to negative 4, negative 3. Then we solve each of them. Okay, we solve each of them. All right. So you take 3 to the x is equal to 4. Okay, take natural log. Take ln on both sides. Okay. That gives me natural log of 3 to the x is equal to natural log of 4. And that gives me x natural log of 3 is equal to natural log of 4. Okay, using the properties. So divide both sides by natural log of 3, natural log of 3. And so you have what? X is equal to what? Natural log of 4 divided by natural log of 3. Okay, then for the other one, you got 3x is equal to negative 3. If you take natural log of what on both sides, okay, this part here is undefined. Okay, because for the natural log to exist, it must be positive, but so you discard. So discard the solution. So therefore, there's only solution set. Okay, there's only solution set to this. Okay, the solution set is going to be what? The natural log of 4 divided by the natural log of 3. And that is it. Okay. If you want to know the approximate solution, natural log of 4 over natural log of 3, let me use my calculator. Okay. So natural log of 4 is equal to, this is 1.38629 4361 divided by the natural log of 3, which will give me 1.098612289. Then when you approximate divide this, you have 1.38629 629,4361 divided by the answer that I just got is approximately 1.26 119. Okay, to 4 decimal places. Okay, so that is approximately that. Perfect. And so that is the end of this section, and the other section will follow suit. Thank you. Bye-bye.